Have you ever wondered how the universe might end? From silent, cold fades to violent cosmic catastrophes, scientists have imagined countless scenarios. In this video, we'll explore 100 fascinating theories about the ultimate fate of everything we know, revealing the mysterious, awe-inspiring, and sometimes terrifying possibilities that await the cosmos. Chapter 1. Imagine the universe slowly losing heat, stars fading into darkness. This is the heat death theory. Energy spreads so thin that nothing can move or grow. Galaxies drift apart, leaving empty space. Time continues, but life cannot. The universe becomes a cold, quiet expanse, a vast cosmic sleep. Even black holes eventually evaporate, leaving only faint whispers of existence. Chapter 2. Some scientists suggest a big crunch. Gravity might one day reverse the universe's expansion, pulling everything back together. Galaxies collide, stars ignite in chaotic bursts, and space folds on itself. Everything condenses into extreme density. It's like pressing the cosmic rewind button. Energy and matter could restart in a new cycle, hinting at the universe's endless rhythm. Chapter 3. The Big Rip. Theory imagines a future where dark energy accelerates expansion forever. Galaxies drift apart faster than light can travel. Stars and planets tear apart. Eventually, atoms themselves could unravel. It's a dramatic end where the universe literally rips at its seams. This scenario depends on the mysterious force pushing the cosmos outward, growing stronger over time. Chapter 4. Quantum mechanics adds strange possibilities. The false vacuum decay theory suggests our universe exists in a metastable state. A sudden shift could create a bubble expanding at light speed. Everything inside it is destroyed instantly. This isn't just theoretical. Physics equations predict such instability could be real. One moment, existence continues. The next, the fabric of reality itself changes. Chapter 5. Another idea is the heat death of black holes. Even these cosmic giants slowly evaporate through Hawking radiation. Over unimaginable time, the last black holes vanish, leaving only diffuse particles. Space empties. Energy is spread thin. Life and stars are gone. The universe becomes a near-perfect void, silent and dark, a reminder of time's relentless, unstoppable flow. Chapter 6. The Big Freeze is subtle but chilling. As the universe expands, galaxies move apart and stars burn out. Light grows dim, temperatures drop, and planets become inhospitable. Life struggles, then disappears. Eventually, matter itself decays. The universe persists, but nothing meaningful remains. It's the slow, quiet death of everything we know, a cosmic silence stretching endlessly. Chapter 7. Some theories suggest a cyclical universe, endlessly reborn. The oscillating universe expands. The likelihood is extremely low, yet the possibility fascinates. It highlights the fragility of existence, showing that even space itself isn't completely stable, and that our universe might be a temporary bubble. Chapter 9. Proton decay is a slow, almost invisible threat. If protons eventually decay, all matter breaks down. Stars, planets, even you disintegrate at the tiniest level. Life becomes impossible. The universe shifts from structured complexity to mere particles drifting in void. It's a quiet, inevitable unraveling, showing that even the smallest building blocks aren't eternal. Chapter 10, Cosmic Collision Theory, predicts massive collisions between galaxies. Over billions of years, gravitational forces can fling stars into chaos, smashing planets and igniting supernova. Even our Milky Way could collide with Andromeda. These collisions reshape space, creating new stars but also threatening any existing life. Cosmic endings can be violent, showing the universe's raw power and unpredictable nature. Chapter 11, The Black Hole Merger Theory, explores the fate of supermassive black holes. Over eons, they collide at galaxy centers, forming even larger black holes. Energy radiates in gravitational waves, shaking space-time itself. Planets and stars near them are destroyed. Eventually, the universe could be dominated by a few massive black holes, lonely and isolated, slowly evaporating in the endless dark. Chapter 12. A cosmic string could reshape the universe's future. These hypothetical defects in space-time carry immense energy. If they collide, the explosion could release more energy than stars produce in billions of years. Space itself might bend or fracture. While purely theoretical, this idea reminds us that hidden structures in the universe could end life as we know it. Chapter 13, Dark Energy Domination, imagines a universe where expansion accelerates endlessly. Galaxies vanish beyond our horizon, unreachable forever. Even light cannot cross the growing gaps. Cosmic structures dissolve, leaving a lonely dark void. Life on isolated planets eventually ends as stars burn out. The universe survives, but meaning and connection disappear into infinite emptiness. Chapter 14, Stellar Burnout, is simple yet inevitable. Stars exhaust their fuel, collapsing or exploding as supernova. Over time, no new stars form. Galaxies fade, leaving cold remnants, white dwarfs, neutron stars, black holes. Without energy sources, life cannot exist. The universe slowly becomes a graveyard of dead stars, a quiet cosmic desert stretching endlessly. Chapter 15, Entropy and Decay, highlight the universe's irreversible march. Matter itself may break down. Even atomic particles might decay. Complex structures vanish. Energy spreads thin. Life becomes impossible. Over unimaginable time, only a sparse cloud of particles remains. The universe exists, but nothing meaningful or organized survives. Time continues, but existence becomes featureless and cold. Chapter 16, The Vacuum Energy Explosion Theory, predicts sudden cosmic catastrophe. A tiny fluctuation in quantum fields could trigger a chain reaction, reshaping space-time. Galaxies, stars, and atoms are instantly destroyed. This extreme possibility reminds us that our universe is a delicate balance. Even minor quantum shifts could end everything in an instant, unseen until it's too late. Chapter 17, Cosmic Inflation Reversal, imagines the universe collapsing after expansion. Space could shrink, energy condenses, and stars crash together. Gravity dominates completely, forming a singularity. This is a variant of the Big Crunch, emphasizing that expansion isn't guaranteed forever. The universe might be cyclical, with every ending birthing a new beginning. a cosmic heartbeat across time. Chapter 18. The axion decay hypothesis suggests dark matter could slowly break down. As these hypothetical particles vanish, gravitational structures weaken. Galaxies drift apart or collapse unpredictably. Planets orbiting stars might be flung into emptiness. This subtle, invisible decay alters cosmic architecture gradually, highlighting how even unseen matter can shape the universe's ultimate fate. Chapter 19. Supernova chain reactions could accelerate cosmic endings. When massive stars explode, they trigger nearby stars' collapse. Over eons, cascading supernova could destroy stellar planets. Neighborhoods. Heavy elements scatter, leaving remnants but no new star formation. Life cannot survive these repeated cosmic shocks. The universe gradually becomes a quieter, emptier space, scarred by the echoes of dying stars. Chapter 20. The multiverse collision theory imagines universes interacting. If another universe merges with ours, extreme energy release could annihilate everything. Space, time, and matter could be replaced or warped. Though purely theoretical, it highlights possibilities beyond our observable cosmos. Endings might not be confined to our universe alone, suggesting the cosmos could face forces beyond imagination. Chapter 21. Neutron star collapse imagines dense stars reaching critical mass. When gravity overwhelms them, they can collapse into black holes. Surrounding matter is ejected in violent bursts of energy. Galaxies slowly lose their stellar population. Over eons, this quiet transformation reshapes cosmic structures. Life becomes impossible as energy sources vanish, leaving cold remnants drifting in darkness. Chapter 22. The white dwarf cooling theory shows a slower ending. These dead stars gradually radiate heat, dimming over trillions of years. Without fusion, planets orbiting them freeze. Eventually, only faint light remains. The universe survives, but its glow fades to near invisibility. Life cannot exist, weaving an endless cold expanse where even light barely persists. Chapter 23. Gamma-ray burst threats. Imagine massive star deaths sending lethal radiation across galaxies. Planets nearby face extinction. Even distant systems can feel effects over eons. These bursts are random yet powerful, reshaping the habitability of entire galaxies. Life survives only by chance. The universe remains. But cosmic violence slowly eliminates potential civilizations. Chapter 24. The proton-proton decay hypothesis predicts matter itself might vanish slowly. Atoms disassemble, stars fade, planets crumble. Over unimaginable timescales, even black holes evaporate. The universe becomes an empty particle cloud. Time continues, but complexity disappears. It's the quiet unraveling of reality itself, highlighting that even fundamental building blocks aren't eternal. Chapter 25. The cosmic void expansion. Theory shows the universe's emptiness growing. Galaxies move beyond visibility. Space stretches endlessly, and light fails to reach us. Structures collapse under isolation. Over time, even clusters dissolve. Life is confined to tiny, fading pockets. The cosmos continues, but isolation and emptiness dominate. A universe stretched thin across infinite distance. Chapter 26. Supermassive black hole decay predicts even giant black holes slowly evaporate through Hawking radiation. Over unimaginable time, Their mass diminishes, releasing faint energy. The cosmic landscape becomes quiet. No stars, no galaxies, just drifting particles. This slow, inevitable process illustrates that nothing, not even the universe's most extreme objects, lasts forever. Chapter 27. The vacuum collapse bubble is a sudden quantum disaster. A tiny change in vacuum energy could spread at light speed, rewriting physics. Everything inside is instantly annihilated. It's unpredictable and invisible until it happens. Reality itself is replaced. This extreme end shows that our universe exists on a fragile quantum edge where one shift could erase all. Chapter 28, Galaxy Collision Chains, explore cascading cosmic mergers. As galaxies collide, stars are flung, black holes merge, and energy erupts in waves. Over billions of years, these events reshape structures. Some regions may survive temporarily, but repeated collisions eventually create chaos. The universe's architecture slowly disassembles, showing how interactions between galaxies can be a hidden agent of cosmic endings. Chapter 29. The entropy limit theory highlights inevitable disorder. Over time, energy spreads thin, matter decays, and systems fail to maintain structure. Stars dim, planets freeze. Life cannot survive. The universe survives. But everything meaningful vanishes. It's a slow, irreversible fade toward maximum entropy, a cosmic reminder that order is temporary in the grand scale of existence. Chapter 30, Cosmic Inflation Failure, imagines the universe's rapid expansion stopping suddenly. Space might collapse or warp unpredictably. Galaxies fall into chaos, stars collide, and matter compresses. Life is destroyed, and energy concentrates into dense points. Though theoretical, it emphasizes how dependent our existence is on precise cosmic conditions. Even slight changes could trigger catastrophic endings. Chapter 31. The Quasar Explosion Theory considers supermassive black holes feeding on gas rapidly. Quasars emit enormous energy, blasting radiation across galaxies. Nearby stars and planets are destroyed. Over billions of years, repeated quasar activity reshapes galactic neighborhoods. Life cannot survive close to such cosmic engines, and the universe slowly becomes a landscape dominated by violent, energetic beacons. Period. Chapter 32, Cosmic Ray Catastrophe, imagines high-energy particles from exploding stars or black holes striking planets. These rays can sterilize surfaces or damage atmospheres. Over eons, civilizations are vulnerable. Though rare, the universe constantly produces these invisible hazards. Cosmic life is fragile, and the universe's energy can be both a creator and destroyer, quietly shaping where survival is possible. Chapter 33, The Dark Matter Instability. Hypothesis suggests unseen matter could shift unexpectedly. Gravity and structure depend on dark matter's balance. If it decays or moves, galaxies scatter, stars lose stable orbits, and planets drift into voids. Life becomes impossible in isolated pockets. The universe remains, but its invisible backbone might collapse, showing how unseen forces can dictate cosmic fate. Chapter 34, Star Cluster Evaporation, occurs as stars slowly leave clusters due to gravitational interactions. Over billions of years, clusters dissolve, stars scatter, and local galactic regions thin out. Energy spreads, and density drops. Life on planets loses the protective stability of stellar neighborhoods. the universe quietly empties, highlighting gradual processes that erode structure without dramatic explosions. Chapter 35, The Neutrino Flood. Theory imagines rare particle events influencing cosmic energy. Billions of neutrinos pass through matter harmlessly, but in extreme scenarios, dense fluxes could alter star behavior. Life remains vulnerable to such unpredictable forces. The universe is full of subtle but persistent processes, showing that endings aren't always violent. They can be silent and unavoidable. Chapter 36, Hypernova chains occur when massive stars explode spectacularly. Their shockwaves trigger neighboring stars' collapse. Over time, these chains reshape galaxies, leaving scattered remnants and black holes. Life is eradicated in affected zones. Cosmic death can be both brilliant and destructive, a reminder that endings can shine even as they destroy everything in their path. Chapter 37, The Photon Exhaustion. Concept explores a future where stars burn out. Light becomes scarce, temperatures drop, and energy is too diffuse to sustain motion or life. The universe survives but fades into dim emptiness. Even radiation decays slowly, leaving a cold, dark expanse. The cosmos remains, but meaningful activity ceases, a silent cosmic winter stretching endlessly. Chapter 38, The Cosmic Shear Theory imagines forces stretching space-time unevenly. This subtle, invisible stress on the universe highlights that endings can be slow, silent, and structural, rather than explosive or immediate. The universe's architecture is fragile. Chapter 39, Micro Black Hole Evaporation, focuses on tiny black holes that radiate energy rapidly. These minuscule objects eventually disappear, releasing bursts of radiation. Though small individually, countless evaporations subtly alter cosmic energy distribution. Over time, even minor objects contribute to the universe's slow fade, showing that endings can arise from both massive and tiny actors. Chapter 40, The Intergalactic Drift Theory, highlights galaxies moving apart indefinitely. Expansion leaves each cluster isolated, unreachable, and lonely. Over trillions of years, communication, travel, and interaction between galaxies are impossible. Life becomes confined to fading islands of matter. The universe survives, but isolation dominates. Cosmic loneliness is the silent, inevitable consequence of endless expansion. Chapter 41, The Cosmic Microwave Background Fade Theory, explores the universe cooling over time. As stars die and expansion continues, background radiation diminishes. Space becomes darker, colder, and emptier. Energy is too diffuse to power new structures. Life vanishes. The universe persists, but without light or warmth, a silent, frozen emptiness stretches endlessly across cosmic horizons. Chapter 42, Supercluster Collapse, imagines enormous galaxy clusters losing gravitational cohesion. Galaxies drift apart or fall into dense regions unpredictably. Stars collide or are flung into voids. Over billions of years, cosmic structure becomes chaotic. Life on planets in affected areas is destroyed. The universe survives, but its large-scale order gradually dissolves into random motion and isolation. Chapter 43, The Exotic Particle Decay Theory, predicts hypothetical particles slowly transform into energy or lighter matter. Over unimaginable time, even invisible components of the universe vanish. Stars, planets, and black holes lose gravitational anchors. The universe becomes a diffuse particle cloud. Life and structure disappear quietly. Emphasizing endings can occur at the tiniest, almost invisible level. Chapter 44, Galactic Cannibalism, occurs when massive galaxies consume smaller neighbors. Stars are torn apart or flung into space, creating chaotic environments. Over eons, large galaxies dominate, leaving only a few isolated clusters. Life is eliminated in disturbed regions. Cosmic endings can be violent yet localized, reshaping the universe gradually, one galactic encounter at a time. Chapter 45, Time Dilation Collapse, imagines areas of extreme gravity stretching time. Planets and stars near black holes age differently, while distant regions move faster. Over cosmic scales, synchronization of processes breaks down. Life struggles to adapt. Though subtle, this effect demonstrates that space-time itself can influence endings, showing the universe isn't uniform and predictable. Chapter 46, The Black Dwarf Era, occurs as white dwarfs cool completely. Stars no longer emit light or heat. Planets orbiting them freeze. Galaxies become collections of dead stars and black holes. Life is impossible. The universe survives, but its vibrant energy is gone. A vast, cold silence dominates, showing the slow, inevitable fade of cosmic activity over unimaginable timescales. Chapter 47, Magnetic Field Decay, considers that galaxies' magnetic fields weaken over time. These fields stabilize stellar and planetary environments. Without them, star formation slows, cosmic rays penetrate unshielded planets, and life becomes impossible. This quiet, invisible process illustrates that cosmic endings can arise from subtle forces shaping environments essential for survival. Chapter 48, Cosmic Filament Stretch, focuses on the universe's large-scale web structure. Expansion stretches these filaments, isolating galaxies and clusters. Energy spreads thin, interactions fade, and structure deteriorates. Over eons, cosmic activity declines. Life becomes confined to rare, stable pockets. Endings can be gradual, driven by the universe's architecture itself, stretching space into emptiness. Chapter 49, The Relic Radiation Dimming Theory, predicts leftover radiation from the Big Bang slowly diminishes as expansion continues. Even light itself fades, leaving mere total darkness. Stars die, galaxies drift apart, and cosmic structures vanish. Life cannot survive. The universe persists, but energy scarcity defines its late stages. A quiet, dim cosmos becomes the final stage of existence. Chapter 50, Gravitational Wave Decay, imagines the universe losing energy from ripples in spacetime. Over time, these waves fade, structures stabilize or scatter, and motion slows. Stars and planets drift into isolation. Life becomes impossible. The universe survives, but its dynamism declines. Even the echoes of massive cosmic events eventually vanish, leaving a silent, still cosmos. Chapter 51, The Void Domination Theory, suggests empty regions of space grow as galaxies drift apart. Cosmic neighborhoods shrink, leaving isolated clusters and solitary stars. Over trillions of years, life becomes confined to rare, stable planets. The universe survives, but emptiness dominates. The expansion spreads matter thin, showing that endings can come from space itself, stretching endlessly. Chapter 52. Cosmic dust accumulation. Imagine stars and planets shedding material over eons. Dust clouds grow, blocking light and cooling regions. Star formation slows, and galaxies fade. Life struggles as energy becomes scarce. This slow, persistent process shows that even tiny particles can influence cosmic endings, gradually reshaping the universe's landscape into dim, cold regions. Chapter 53, White Hole Speculation, theorizes the opposite of black holes, objects expelling matter, instead of absorbing it. If white holes exist, they could disrupt nearby stars, planets, and energy flows. Cosmic structures may be torn apart unpredictably. Life is vulnerable to such events. The universe contains mysterious possibilities, showing endings can come from unexpected, exotic forces hidden in space. Chapter 54, Gravitational Collapse Chains, predict regions of high density triggering cascading collapses. Stars, clusters, and even galaxies can be pulled into singularities. Energy releases in bursts of radiation. Over time, these chains slowly reduce cosmic structures. Life is destroyed locally, while the universe continues. Endings can be subtle yet powerful, operating silently across vast scales. Chapter 55, The Cosmic Horizon Isolation Theory, shows distant galaxies disappearing beyond observational reach. Light can no longer reach us. Interaction between galaxies becomes impossible. Over trillions of years, civilizations become confined to single clusters. The universe persists, but meaningful connection fades. Cosmic isolation becomes a silent, inevitable consequence of continuous expansion. Chapter 56, Exotic Star Phase, imagines stars entering rare, unstable forms, burning unpredictably. Their energy output fluctuates, triggering local chaos. Nearby planets may be destroyed or uninhabitable. While uncommon, these stellar phases gradually alter galactic neighborhoods. Life cannot adapt to such extremes. The universe remains, but instability reshapes structures quietly over time. Chapter 57, Proton Decay Consequences, highlight the eventual disintegration of matter itself. Atoms crumble, stars vanish, and planets dissolve. Life becomes impossible over unimaginable space-time. Timescales, even black holes fade. The universe survives in form, but loses all complexity. It's the ultimate reminder that endings can emerge from the tiniest building blocks, invisible yet inevitable. Chapter 58, Interstellar Medium Depletion, explores how galaxies exhaust gas needed for new stars. Star formation slows and eventually stops. Galaxies fade into remnants of old stars and black holes. Life is confined to remaining stars temporarily. The universe survives. But creative energy disappears. Cosmic endings can arise from resource exhaustion, slowly starving space of its ability to sustain activity. Chapter 59, Neutrino Flux Gradients, describe how invisible particle streams shape galactic evolution. Though weak, neutrinos influence energy distribution over billions of years. Subtle shifts can alter stellar behavior, triggering collapses or slowing formations. Life is affected indirectly. Endings don't always come from explosions. They can emerge from persistent, nearly invisible forces acting silently across the cosmos. Chapter 60, Dark Energy Growth, predicts acceleration of universal expansion. Galaxies are flung beyond reach, stars drift apart, and clusters dissolve. Even gravity cannot bind structures. Life becomes impossible on isolated planets. Over trillions of years, the universe stretches thin, energy dilutes, and darkness dominates. This demonstrates that subtle, persistent forces can define the ultimate fate of everything. Chapter 61, The Cosmic Bubble Collapse Theory, imagines pockets of space with slightly different energy densities. Some bubbles might collapse, wiping out stars and matter inside instantly. Expansion continues elsewhere, leaving isolated surviving regions. Life is destroyed locally. This theory shows that the universe's fate can vary by region, with some areas ending catastrophically while others persist quietly. Chapter 62, Gravitational Wave Effects, predict energy loss from massive cosmic events. Over billions of years, waves subtly alter star orbits and galaxy structures. Clusters shift, planets drift, and life is threatened. Even slow, invisible forces like these shape the universe's ending. It's a reminder that not all cosmic endings are dramatic. Some are quiet, persistent, and inevitable. Chapter 63, Hypercompact Stars, might form from collapsing massive stars or unusual matter. These stars emit extreme radiation, destroying nearby systems. Life cannot survive their environments. Over time, such exotic objects could dominate isolated regions, gradually eliminating habitable space. The universe continues, but these rare, dense stars demonstrate how unusual processes can shape cosmic fate. Chapter 64, The Cosmic Web Stretching. Theory highlights large-scale structure. Filaments of matter connecting galaxies are pulled apart as expansion accelerates. Energy spreads thin, clusters isolate, and interactions diminish. Life is confined to surviving systems. Cosmic endings can be gradual, driven by structural changes at the largest scales, slowly turning a vibrant universe into sparse isolation. Chapter 65, Exotic Particle Erosion, explores how theoretical particles slowly decay into energy. Matter loses cohesion, stars lose mass, and black holes evaporate. Over unimaginable time, complexity vanishes. The universe survives as diffuse energy and particles. Endings can start at microscopic levels, showing that even invisible components play a role in shaping the final stages of existence. Chapter 66, Supernova-Induced Extinction, predicts cascading explosions in dense stellar regions. Shock waves destroy planets and destabilize orbits. Life cannot survive these repeated cosmic catastrophes. Over billions of years, such chains reshape galaxies, leaving remnants and black holes. Cosmic endings can be violent yet gradual, unfolding silently across vast distances and timescales. Chapter 67, Dark Matter Redistribution, imagines the invisible mass slowly drifting or decaying. Galactic structures lose cohesion, stars drift, and planets may be flung into voids. Life becomes impossible. Over eons, the universe becomes more empty, highlighting how unseen matter controls cosmic evolution and endings. subtly orchestrating the ultimate fate of everything. Chapter 68, Stellar Core Collapse, occurs when massive stars exhaust fuel and collapse into black holes or neutron stars. Nearby systems are affected by radiation and gravity. Life struggles to survive in unstable regions over billions of years. These collapses reduce habitable zones and reshape galaxies. Cosmic endings often come from repeated local stellar processes quietly reshaping space. Chapter 69, The Cosmic Radiation Dimming Theory, predicts leftover energy from the Big Bang slowly decreases. Space cools, stars fade, and galaxies become isolated. Light becomes rare, and life cannot persist. The universe survives physically, but meaningful activity ceases. This demonstrates that energy scarcity alone can drive the ultimate cosmic ending, a quiet fade rather than a dramatic event. Chapter 70, Intergalactic Drift Acceleration, describes galaxies moving apart faster as dark energy dominates. Interactions cease, clusters isolate, and planets lose contact with the universe. Life is confined to shrinking, habitable regions. Over trillions of years, the universe becomes sparse, dark, and silent. Endings can arise from constant acceleration, showing that even persistent, slow forces can define cosmic fate. Chapter 71, The Cosmic Horizon Collapse Theory, predicts regions of space may become inaccessible as expansion accelerates. Galaxies drift beyond observation and interaction. Life is confined to tiny, isolated clusters. Over trillions of years, the universe becomes a collection of lonely islands. Endings can emerge from isolation itself. A silent and inevitable consequence of relentless expansion. Chapter 72, Proton-Level Disintegration, imagines the slow decay of fundamental particles. Atoms crumble, matter dissolves, and stars vanish. Over unimaginable timescales, even black holes fade. Life becomes impossible. The universe remains in form, but loses complexity. This theory highlights that the tiniest building blocks hold the key to the universe's ultimate fate. Chapter 73, Cosmic Void Domination, explores how empty space gradually overtakes structured regions. Galaxies drift apart, clusters thin, and interactions diminish. Life survives only temporarily in isolated pockets. Over trillions of years, emptiness dominates the cosmos. This slow, inevitable process shows that endings can be gradual, driven by the expansion and thinning of space itself. Chapter 74, White Dwarf Radiation Fade, predicts dead stars slowly lose remaining energy, planets orbiting. Them freeze and galaxies dim. Life cannot survive. Over immense time, even these remnants vanish. The universe persists physically, but becomes a cold, dark, silent expanse. Cosmic endings can be subtle, yet unstoppable, a gradual fade rather than dramatic explosions. Chapter 75, Stellar Neighborhood Collapse, occurs when gravitational dynamics destabilize clusters of stars. Stars drift apart or collide. Planets are flung into voids or destroyed. Life is eliminated locally. Over billions of years, these small-scale collapses accumulate, gradually eroding galactic structure. Endings can come from cumulative local events rather than single catastrophic moments. Chapter 76, The Dark Energy Surge Theory, predicts sudden increases in expansion rate. Galaxies are separated faster, stars drift into isolation, and clusters lose cohesion. Life on remaining planets becomes impossible. The universe survives, but meaningful interaction ceases. Even subtle changes in expansion can redefine the cosmic landscape, driving endings quietly yet inexorably. Chapter 77, Neutrino Flux Instability, describes rare fluctuations in particle streams affecting galactic structures. Stars may shift or collapse unpredictably. Over eons, these subtle effects accumulate, impacting life indirectly. Cosmic endings do not always require dramatic events. Persistent, invisible forces like neutrinos can reshape the universe silently across vast scales. Chapter 78, Hypernova Shockwaves, predict massive stellar explosions sending destructive energy across galaxies. Nearby planets and stars are destroyed, destabilizing regions. Life cannot survive these. Repeated cosmic events. Over billions of years, hypernova chains reshape galactic environments. Endings can be violent yet gradual, leaving behind a quieter, altered universe in their wake. Chapter 79, Cosmic Filament Dissolution, occurs as expansion stretches the universe's large-scale structure. Filaments connecting clusters thin and break, isolating galaxies. Energy spreads thin, interactions vanish, and habitable zones shrink. Life survives only temporarily. Cosmic endings can arise from structural decay at the largest scales, a slow transformation rather than sudden destruction. Chapter 80, The Gravitational Energy Drain Theory, predicts the universe gradually loses kinetic energy over vast timescales. Stars slow, clusters disperse, and planets drift into emptiness. Life is confined or eliminated. Over trillions of years, motion ceases almost entirely, leaving a silent, dark cosmos. Endings can arise from energy loss, a subtle yet unstoppable cosmic process. Chapter 81, The Black Hole Isolation Theory, predicts supermassive black holes dominate empty regions as stars fade. Galaxies lose cohesion, stars drift, and planets orbit only remnants. Life becomes impossible. Over trillions of years, these isolated giants slowly evaporate. Cosmic endings can arise from concentration and eventual disappearance of the universe's most extreme objects. Chapter 82, Vacuum Instability Events. Imagine sudden quantum shifts altering space-time. A tiny fluctuation could create a bubble traveling at light speed, annihilating everything it touches. Life is instantly destroyed within the affected region. Even though rare, this theory highlights that the universe exists in a delicate balance, where one small change can erase all existence. Chapter 83, Galactic Starvation, occurs as gas for new star formation runs out. Existing stars burn out, galaxies fade, and planets lose energy sources. Life struggles and ultimately fails. Over billions of years, cosmic structures decay. Endings can be slow and quiet, driven by depletion of resources necessary for sustaining activity across the universe. Chapter 84, The Cosmic String Collision Theory, explores hypothetical defects in space-time carrying immense energy. If two collide, massive energy releases could tear nearby structures apart. Galaxies, stars, and planets are affected unpredictably. Life becomes impossible locally. Even theoretical, exotic phenomena could define catastrophic cosmic endings beyond conventional astrophysical processes. Chapter 85, Neutron star mergers, generate extreme energy and gravitational waves. Surrounding planets and stars face destruction or destabilization. Over billions of years, Repeated mergers reshape galaxies. Life is eliminated in affected zones. Cosmic endings can arise from recurring, high-energy events rather than a single final act, quietly restructuring the universe over time. Chapter 86, The Photon Scarcity. Theory predicts fading light as stars exhaust fuel and expansion stretches space. Energy becomes too diffuse to sustain activity. Life disappears. Over trillions of years, the universe becomes dim and cold. Endings can be gradual, resulting from the slow decline of energy rather than sudden cataclysms. A silent fade into darkness. Chapter 87, Interstellar Drift. Imagine stars and planetary systems slowly moving apart as expansion accelerates. Galaxies isolate, clusters disperse, and interactions vanish. Life survives temporarily in rare, stable regions. Over eons, the universe becomes empty and cold. Cosmic endings can be driven by persistent motion at immense scales, gradually eroding structure and connectivity. Chapter 88, The Proton Decay Cascade, predicts fundamental particles disintegrate, leading to the collapse of atoms, stars, and planets. Life is impossible. Over unimaginable timescales, even black holes fade. The universe survives as dispersed energy and particles. Endings can emerge from the tiniest components, invisible yet inevitable, reshaping the cosmos slowly and irreversibly. Chapter 89, Gravitational Collapse Webs, highlight cascading effects in dense regions. Stars, clusters, and galaxies fall into singularities, releasing bursts of energy. Life is destroyed locally. Over billions of years, these collapses accumulate, subtly reshaping the universe. Endings can result from repeated small-scale events that quietly alter cosmic architecture over immense time. Chapter 90, The Multiverse Interaction Theory, speculates another universe could intersect ours. Energy release and space-time distortion could annihilate regions instantly. Life is destroyed in affected zones. While purely theoretical, this shows cosmic endings may not be confined to our universe alone. Forces beyond comprehension could determine the ultimate fate of existence. Chapter 91, The Hypercompact Remnants Theory, predicts dense, exotic stars dominate isolated regions. Their gravity and radiation destroy nearby planets and destabilize systems. Life cannot survive. Over trillions of years, these objects slowly evaporate or fade. Cosmic endings can be governed by rare, extreme objects, quietly reshaping the universe's late-stage landscape. Chapter 92, Cosmic Radiation Drain, imagines leftover energy from stars and the Big Bang gradually fading. Light becomes scarce, temperatures drop, and galaxies dim. Life disappears. Over unimaginable time, the universe survives physically, but becomes cold, silent, and empty. Endings can be gradual, driven by energy depletion rather than dramatic explosions. Chapter 93, White Hole Emergence, speculates on objects expelling matter violently. If they exist, they could disrupt stars and planets locally. Life becomes impossible nearby. Even rare and exotic phenomena may shape endings. The universe contains unknown forces that could abruptly alter cosmic structures, emphasizing that endings may come from unpredictable, hidden sources. Chapter 94, Prolonged Stellar Burnout Theory, highlights that stars slowly exhaust fuel. Galaxies dim as supernovae fade and planetary systems lose energy. Life cannot survive indefinitely. Billions of years, the universe becomes a quiet, cold expanse. Cosmic endings can be subtle, arising from inevitable stellar processes quietly reshaping the cosmos. Chapter 95, Dark Matter Drift, explores how invisible mass slowly shifts or decays. Galaxies lose cohesion, stars drift, and clusters thin. Life becomes impossible in isolated regions. Over trillions of years, cosmic structures unravel. Endings can be silent, yet unstoppable, dictated by unseen forces forming the universe's hidden framework. Chapter 96, Neutrino-Induced Collapse, imagines particle streams subtly influencing galactic structures. Over eons, shifts can destabilize stars and clusters. Life is affected indirectly. Endings may come from subtle, nearly invisible processes rather than explosions, showing how the universe is shaped by forces beyond direct perception. Chapter 97, Cosmic Expansion Overdrive, predicts relentless acceleration of the universe. Galaxies move beyond each other's reach, clusters isolate, and interactions vanish. Life becomes confined or impossible. The universe survives physically, but isolation and emptiness dominate. Persistent forces can define endings quietly yet inevitably across vast cosmic scales. Chapter 98, Vacuum Energy Shift, considers sudden changes in quantum fields. A small fluctuation could rewrite physics locally or universally. Galaxies, stars, and planets may be destroyed instantly. Life is erased in affected regions. This extreme scenario shows that cosmic endings can occur from tiny quantum events with consequences beyond imagination. Chapter 99, Intergalactic Stellar Migration, imagines stars slowly drifting across clusters due to gravitational interactions. Over billions of years, planets are flung into voids or destroyed. Life disappears in destabilized systems. Cosmic endings can be subtle, arising from persistent motion that quietly reshapes galactic architecture over immense timescales. Chapter 100, The Ultimate Heat Death, combines multiple theories. Stars fade, black holes evaporate. Energy spreads thin, and particles decay. The universe becomes cold, dark, and empty. Life and structure vanish entirely. Time continues, but existence is featureless. This ultimate ending shows that in the vast scale of the cosmos, endings are inevitable, silent, and irreversible. These 100 theories remind us that the universe is vast, mysterious, and ever-changing. Whether it ends with a bang, a whisper, or a slow fade, one thing is certain: the cosmos continues to surprise and inspire. Thank you for watching, and keep looking up, because the universe's story